What's going on, ladies and gentlemen? Thank you so much for tuning in. It don't look like me. This morning we are in Lido Beach. Lido Beach is on the barrier island between the Atlantic Ocean and Long Island in Nassau County in the great state of New York. We have a Hayward Heat Pro heat pump pool heater. It's not heating. Customer's getting an error of LP. Let's check this out. Yep. This baller status right here. There's no hose from the backwash? Oh my God. Damn. People spend millions of dollars on their pools and they don't even put the pipe in.
I do it backwards because I don't know if that is the reason.
Ah. Alright. Well, now we have no pump. Okay. And we have the hum. We got the hum. Watch this. Which way is direction of flow? Could be that way? Yep. Okay, so far so good. All right, so I just pulled the front cover off. We had 3 screws on top, 2 in the bottom, and keeping my feet dry, my boots dry, I was able to get those 2 screws out without having to get over there. So if you recall, just moments ago, we turned on the system. We had no flow. We got restored flow with the pump, and our fan was just humming, and it was not operating. I gave that a little push start, and now she's running. Let's open up the front cover like that, and let's check everything out. Make sure everything is copacetic. Okay. That is going to our pressure switch. Okay. So, let's just do a quick little identification for those of you who may be new to this, okay? That's our transformer. It's taking line voltage, so it's a step-down transformer. It's taking line voltage, which is 220 volts, 210, 240, and it's stepping that down to 24 volts, okay? Because our control circuitry is 24 volts, okay? There's our compressor just kicked on, by the way. Right here, if you do HVAC, you're going to recognize that. That is called a contactor. It will take a 24 volt signal that energizes a coil and closes contacts between the line side and the load side. So incoming to load. Just check to see what we got there. 64 degrees still. We may run into an issue because air is taking the path of least resistance with the covers off. So we may have to get back to that in a second, but she's still running, which is a good thing. Right there, that is our flow switch or pressure switch. This right here is this larger barrel looking thing. That's called a capacitor, a run capacitor. That's 80 microfarads. And the smaller one right there, ovalish, it's also a capacitor, and that's the fan capacitor, and that's 7.5. So this is the capacitor for the compressor. This is the capacitor for our condenser fan motor. Now, if we were to turn off power here, okay, and we kill power to the unit, we'll go to that box next, we're going to see what the values of these 2 parts are. All right, heat pump. Let's kill that. Let's make our way back over there. Power's off. Let's discharge any remaining juice that may be stored in these capacitors. Let's remove the 2 brown wires from the top of the capacitor. And then let's also remove the 2 blue wires from the hermetically sealed compressor capacitor. All right, now using my Fluke 902 FC, we're going to read capacitance. And we're going to see we have 0.8. I have one lead on one terminal and another lead on another, and we're getting 0.8. So this capacitor is dead. Let's check out the other one. That's there and there. And we're getting 81.2. So our 80 microfarad capacitor is fine. Our 7.5, well, she's kaput. All right, I have both capacitors secured now. I put in the AMRAD. This is their round capacitors, what we stock on the trucks. I took a Sharpie, wrote today's date on it, 5/8/24. I made sure that you can actually see the rating of it. So if the next guy who comes here, you can see it without actually taking it out to look at it. And I took a piece of band iron and a couple 5/16 screws, and I screwed that in there. These are nice and tight. It's not going anywhere. I clipped the ends of the ears right there just in case it vibrates and these wires get in the way. You don't want to have any shorts, electrical shorts, shorting to ground here. So that's all good in there. This was back in there like that. Let's close her up and let's cycle her up and see how she runs. Voila. All right, after about a 120-second delay of just the fan running after a call for heat, the compressor kicked on, and we do have nice cold discharge temperature coming out of the top of the heat pump. Our cool temperature is 64 degrees. I'm going to use my digital psychrometer. Let's take some temperature readings, ambient and discharge, and then we're going to take a temperature reading of the outlet, the jets by the pool. Okay. Ambient temperature looks like it's around 60 degrees. All right. Still cooling off. Looks like we are at 52.2 degrees. 52 degrees. Okay. All right. Again, using the Fluke 902 FC, I'm reading an ambient temperature over here of around 64 degrees. Let's go to that jet right there. And let's see what our discharge temperature is. All right. We're inside. And it looks like we're almost at 72 degrees. Okay. All right, ladies and gentlemen, thank you so much for tuning in. If you are in the New York City, Long Island metropolitan area and you have a pool heater, you need some help, give me a call. I'd love to help you. 516-348-6300. You can also email me at mike@pipedoc.net. We service all brands, Hayward, Jandy, Raypak, just to name a few. Thank you so much for watching. If you wouldn't mind, please hit that thumbs up button down below and subscribe if you haven't done so already. And as always, thoughts, feedback, even criticism, down in the comment section down below. Thank you so much. Be well. God bless. Stay safe.